Yes, students, let us have a concept-oriented application. What is that? If a variable line in two adjacent positions has DCS L, M, N, L plus dou L, M plus dou M, N plus dou N. These are the DCS of a line in two positions. And dou theta is the small angle between the two positions. Then dou theta whole square is equal to dash. He has given the variable line has a DCS in two adjacent positions. Nevertheless, these are the DCS of a lines. Now what I can write is, now the proof of this one is very simple. L, M, N, L plus dou L, M plus dou M, N plus dou M be the DCS of line, okay, of lines. Okay, now I can write, which implies L square plus M square plus N square is equal to 1. We know it. Meanwhile, L plus dou L whole square, that is M plus dou M whole square, N plus dou N whole square is equal to 0. Followed? Why? These two are the DCS of a lines, correct, in two positions. So therefore, now these are the direction cosines. I can write it's a 1. So now you expand it. This becomes L square plus M square plus N square. Expand this. Here L square, dou L square, 2 into L into dou L. M square, dou M whole square, 2M into dou M. That is N square, dou N square, 2 into N into dou N, right? Plus dou L whole square, dou M whole square, dou N whole square, right? Plus I can write L into dou L, M into dou M, N into dou N is equal to 1. But L square plus M square plus N square is equal to 1. So therefore 1 plus dou L whole square, dou M whole square, dou N whole square plus 2 into, come on, L dou L, that is M dou M, N dou N is equal to 1. Now this and this get cancels. You transfer that side. I can write dou L whole square, dou M whole square, dou N whole square is equal to, it's now I can write minus 2 into L dou L, M dou M, N dou N. You call this as a result number 1. Next comes about dou theta. Dou theta is the angle between, dou theta is the angle between two positions of a line having DCS L, M, N and L plus dou L, M plus dou M, N plus dou N. If L1, M1, N1, L2, M2, N2 be the DCS of two lines and theta is the angle between them, then cos theta is equal to L1, L2 plus M1, M2 plus N1, N2. Here this is taken as L1, M1, N1. This is taken as L2, M2, N2. Now I can write that is a cos of dou theta. Instead theta, we are given with dou theta is the angle between the lines in two adjacent positions. So therefore cos dou theta is equal to L1 L2 L into L plus dou L M into M plus dou M plus N into N plus dou N, right? Followed? Therefore, I can write cos dou theta is equal to L square L into dou L M square M into dou M N square plus N into dou N, right? Okay, so therefore I can write this as L square M square plus N square plus I can write L into dou L M into dou M N into dou N. Followed? So therefore next I can write cos dou theta is equal to 1 plus L into dou L M into dou M N into dou N. Now you transfer this is minus of or else minus 1 plus cos dou theta is equal to L into dou L M into dou M N into dou N, right? Followed? So therefore now take minus common 1 minus cos dou theta is equal to L into dou L M into dou M N into dou N. Followed? Right? So therefore now this is nothing but 2 sine square dou theta by 2. 2 sine square dou theta by 2 is equal to L into dou L M into dou M N into dou N. Followed? We know that already the range of sine is minus 1 to 1, close interval. Sine square is what? 0 to 1. Means, now look here, this value is always less than or equal to 1, correct or not? I can write this as now L into dou L plus M into dou M N into dou N is less than or equal to minus 2 into, yes, come on, less than 2 into, that is dou theta by 2 whole square, less than or equal to 1. So therefore I can write L into dou L M into dou M N into dou N is less than or equal to minus dou theta whole square by 2. 4 comes, 2 to get cancels. You call this as what? 2. Yes, now you can very well observe from 1 and 2. Now in place of this you can substitute this, right? Now you can cross multiply 2, right? So now this becomes, now from 1 and 2 I can write dou L whole square plus dou M whole square plus dou N whole square is equal to dou theta whole square. This is how you can prove dou theta whole square is equal to dou L whole square plus dou M whole square plus dou N whole square is equal to dou theta whole square. Now look here, let us recall in detail. LMN, L plus dou L, M plus dou M, N plus dou N are the DCS of the line in two adjacent positions, and angle between them is what? Dou theta. So therefore when they are DCS of a line, we know that the relation between direction quotients of a line segment, L square plus M square plus N square is equal to how much? 1. Next, L plus dou L whole square plus M plus dou M whole square plus N plus dou N whole square is equal to 1. Now you expand this, that is A plus B whole square, A square plus B square plus 2AB, L square plus M square plus N square, I wrote it here, dou L whole square plus dou M whole square plus dou N whole square plus 2AB, 2 into L dou L plus M dou M plus N dou N is equal to how much? 1. Now I can write, this becomes 1. Come on, expand this one as, you got it, dou L whole square plus dou M whole square plus dou N whole square is equal to minus 2 into this, you call it as 1. As dou theta is the angle between two positions of a line having a DCS, LMN, L plus dou L, M plus dou M, N plus dou N. Got it? So therefore, now what is the angle between the two lines? Cos theta is equal to L1 L2 plus M1 M2 plus N1 N2. Instead of theta, I have taken 2 theta. Therefore, L1 L2 M1 M2 N1 N2. Now you multiply L square plus M square plus N square. Now L dou L plus M dou M plus N dou N. This is equal to 1. Transfer this side. That is 1 minus cos dou theta minus outside. You got it. This is nothing but minus 2 sine square dou theta by 2. But sine square value is what? Always less than or equal to 1. So therefore, I can write minus 2 into dou theta whole square by 2. So therefore, L dou L plus M dou M plus N dou N is less than or equal to minus dou theta whole square by 2. From 1 and 2, here also minus, here also minus. You can substitute that value. In place of this, you substitute this value. So therefore, this becomes L dou L whole square plus dou M whole square plus dou N whole square is equal to what? Dou theta whole square. Right. By using the concept of direction ratios and direction cosines, let us find out the angle between the two diagonals of a cube, the angle between the diagonal of a cube and a face diagonal, the angle between diagonal of a cube and the edge. We are supposed to find out. Let us see what are the concepts. The concept is, the very first one is, in a cube, the angle between, first one, the angle between two diagonals of a cube. Second one, the angle between diagonal of a cube and face diagonal. Third one is the angle between the diagonal of a cube and its edge. Is dash. Now coming this one is, in a cube, the angle between two diagonals of a cube. Next, the angle between diagonal of a cube and the face diagonal. And the face diagonal, if you want, you can take here. And the face diagonal. Next, the angle between the diagonal of a cube and its edge. Let us see how to find out. Let us take, this is cube, you take y-axis, you take this as x-axis, A, origin, B, this is z-axis, you take C. Now this is D, this is G, this is E, this is F. O, A, D, B, E, F, OA, OA, DB, EG, CF is a cube. Okay, the length of this each edge is, let it be A units, A. So therefore, now coming this one is, when O is the origin, you take this point A as A, 0, 0, B as 0, B, 0, C as 0, 0, A. Okay, the length of edge, each edge is what? A. Therefore, its coordinates along x, y and z axis respectively are A, 0, 0, 0, A, 0, A, 0. Next, 0, 0, A. So now let us start. Now, D is a point in xy plane. I take this point as A, 0. Next, E. Now, E is a point in yz plane. You take this point as 0, A. F is in what? Zx plane. A, 0, A. And G is a point in a space A, A. It's in space A, right? You can very well observe in a cube there are 4 diagonals, namely OZ, AE, DC, BF. What is that? OZ, AE, DC, BF. Now I am supposed to find out, the very first question is the angle between the 2 diagonals of a cube. Let us consider 2 diagonals as OZ and AE. Let us find out the direction ratios of 2 diagonals. Okay, now let us start. The proof of this one is very simple. Let O, A, B, C, D, F, G be a cube. And OA is equal to A, OB is equal to A, OC is equal to A, which implies A is equal to A, 0, 0, B is equal to 0, A, 0, C is equal to 0, 0, A. Right? Now let us find out, okay, in a cube, A, that is OZ bar, AE bar be the diagonals. Therefore, DRS of OZ bar, O is 0, 0, 0, x1, y1, z1, x2, y2, z2, x2 minus x1, a minus 0, a minus 0, a minus 0, a is nothing but 1, 1, 1. How come, sir? When A, B, C are the DRS of a line, then KA, KB, KC, A by K, B by K, C by K are also DRS of a same line. Therefore, I could write as 1, 1, 1, 1. Next, DRS of, okay, DRS of AE bar. A is A comma 0 comma 0. E is 0 comma A comma A. E is a point in a YZ plane. It is quite obvious x coordinate is equal to 0. So therefore, AE, now I can write, yes, A minus 0, 0 minus A, 0 minus A. I can write A minus A minus A. So therefore, DRS of AE bar, I can write minus 1, 1, 1, right? Now, let us go for, what is that? DRS of OD bar. What is the DRS of OD bar? A minus 0, A minus 0, 0. Therefore, this is equal to A 0, 1, 1, 0. Got it? Now, let us find out the very first problem. What is first one? The angle between diagonals of a cube. So therefore, now theta be an angle between two diagonals OZ comma AE. Therefore, cos theta is equal to, now cos theta is equal to A1 A2 plus B1 B2 plus C1 C2 by square root of A1 square plus B1 square plus C1 square into square root of A2 square plus B2 square plus C2 square. Let us write, that is A1 A2 B1 B2 C1 C2 by A1 square B1 square C1 square. I can write A2 square B2 square C2 square. Now I can write here only, now you consider as A1 B1 C1 A2 B2 C2. Therefore, A1 A2 1 into minus 1 plus 1 into 1, this is 1 by root 3, this is also root 3. Why? Square root of A1 square plus B1 square plus C1 square, that is square root of 1 plus 1 plus 1, root 3, that's also root 3. Now I can write, this is minus 1 and 1 get cancels, therefore it becomes root 3. Now listen here, the angle between two diagonals of a cube is given by cos theta is equal to 1 by root 3. Nevertheless, theta is equal to cos inverse of 1 by root 3. Followed? Next, when we have found out the angle between the two diagonals of a cube, OZ and AE, as theta is equal to cos inverse of 1 by root 3, let us see what is the angle between the diagonal of a cube and the face diagonal. From the figure, you can very well observe OD is the face diagonal. Therefore, let us find out the angle between OZ bar and OD bar. OZ bar and OD bar. Followed? OZ bar and OD bar. So therefore, why it is very convenient for us, right? Now let us start. Second one is, what is second one? Theta be an angle between OZ bar and OD bar. OZ is the diagonal of a cube. OD is the face diagonal. Let us see once again. Cos theta is equal to OZ is taken as A1, B1, C1 and OD A2, B2, C2. Now let us write A1, A2, right? A1, A2. So therefore 1 into 1, 1 plus 1 into 1, 1, 1 plus 1 into 0 by square root of, that is 1 plus 1 into square root of 1 plus 1 plus 0, right? Therefore, I can write 2 by root 3 into root 2. I can write root 2 into root 2 by root 3 into root 2. Nevertheless, I can write this one as 2 by root 3. Therefore, theta is equal to cos inverse of 2 by root 3 is the angle between the diagonal of a cube and a face diagonal. Students, don't have the overlapping about this. Try to have the clarity. The angle between two diagonals is theta is equal to cos inverse of 1 by root 3, that is 1 by 3, root 3 into root 3. It's what? 1 by 3. You can take 1 by 3. Next, the angle between the diagonal of a cube and the face diagonal is square root of 2 by root 3, right? Okay, here it is root 3 into root 3, it's a 1 by 3, okay? It's a 1 by 3. Now, coming to, this is a face diagonal and a diagonal. The third one is, what is that? The third one is the angle between the diagonal of a cube and the edge of it. Edge of it means edge of a cube. So therefore, now what I can do is, let us take theta. Theta be an angle between that is OZ bar and OD bar. Okay, this is OD bar, that is OB bar. Let us take OB bar. OB bar is a one edge. You can take OA, you can take OC also, but it is OB is convenient for us to see the figure. So therefore, what I can write is cos theta is equal to, now, so here, what is common B? B is nothing but A. I can write this one as 0, 1, 0, correct? So you know already, I can write OB. So therefore, what is common? DRS of OZ bar, DRS of OZ bar 1, 1. Then DRS of what? OB bar is 0, 1, 0. 0, 1, 0. Right. So therefore, now what I can write is cos theta is equal to A1, A2, 1 into 0, B1, B2, 1 into 1, 1 into 0 by root 3 into root 1. So therefore, I can write this one as 1 by root 3, right? So therefore, now I can write theta is equal to cos inverse of 1 by root 3. Yes, the angle between the diagonal of a cube and edge of it is, that is theta is equal to cos inverse of 1 by root 3. What is the angle between the diagonal of a cube and a face diagonal? Theta is equal to cos inverse of 2 by root 3. What is the angle between two diagonals of a cube? That is 1 by 3. Theta is equal to cos inverse of 1 by 3. So therefore, be clear in your context. What is that? In a cube, the first one is in a cube, the angle between two diagonals. I told there are four diagonals. One is OZ, next AE, next BF, next CD, correct or not? Next, that is DC, here DC, this is BF. So therefore, you can take any two diagonals. This arguments, this application not only what applicable for this OZ and what common AE. You can also go for what BF, right? Okay, BF with OZ, BF with what common, that is CD with what OZ also, you can go for it. So therefore, now the angle between two diagonals of a cube is theta is equal to cos inverse of 1 by 3, and here angle between the what diagonal of a cube and the face diagonal is what cos inverse of square root of 2 by 3. Angle between diagonal and the edge is what theta is equal to cos inverse of 1 by root 3. Right. If a ray or a line makes an angles alpha comma beta and gamma delta with the four diagonals of a cube, then cos square alpha, cos square beta, cos square gamma, cos square delta, we have to prove that is equal to 4 by 3. Now let us see what I can do is, this is O, A, x-axis, this is Y, B, z-axis, C. This is origin. Okay, now this is D, this is G, this is what? E, this is F. Now you can very well observe, this is the diagonal of a cube. Next, let us see what I can write is, in a cube, OA, B, C, D, E, F, G, let OA is equal to A, OB is equal to A, OC is equal to what? C, A, which implies A is equal to A comma 0 comma 0. Now B is equal to 0 comma A comma 0. C is equal to 0 comma 0 comma A. Now let us see what I can write is, now G is a point in a space. Now G is a point in space as we discussed earlier. Now G is a point in a space and D is a point in xy plane, E is a point in yz plane, F is a point in what? Zx plane. According to the what? Presence of the coordinate planes, the coordinates of them will be there. So therefore what I can write is, now G is a point in space, I can write A comma A comma A. Now D is equal to, right, D is equal to, it's a point in xy plane, A comma 0. E is a point in what? yz plane. This is 0 comma A comma A. Next, F is equal to, yes, come on, A comma 0 comma A. Now O is taken as 0 comma 0. So therefore, now let OZ, next AE, next BF, next CD, or else, okay, CD, or the four diagonals, be the four diagonals of a cube. Therefore, DRS of OZ bar, DRS of OZ bar. Now this is O is 0, 0. This becomes A minus 0, A minus 0. Therefore, 1, 1, 1. When A, B, C are the DRS, K, A, K, B, K, C, A by K, B by K, C by K are also DRS of a line. Next, DRS of, yes, come on, AE bar. DRS of AE bar is given to be, now AE bar, this is what? A 0, 0, A minus 0, A, 0 minus A. Therefore, A minus A minus A. I can write minus 1, 1, 1, right? Next, DRS of BF bar. DRS of BF bar. B is this, F is here, right? Now 0 minus A, right? Minus A. A minus 0, A. 0 minus A, minus A. I can write 1 minus 1. This is 1, right? This will be 1. Next, DRS of, yes, come on, DC bar or CD bar, as you please. Now, DC bar. Now, D is here, A, 0. C is here. So, therefore, A minus 0, that is A. Next, A minus 0, A minus A. I can write 1, 1, minus 1. Yes, we got DRS of 4 diagonals. Let the DRS of required line or a ray are proportional to L, M, N. Here we are taking it as direction ratios. So therefore, what I can write is L, M, N. So now, let alpha, look here, let alpha be an angle made by line with OZ bar. Therefore, cos alpha is equal to A1A2 plus B1B2 plus C1C2 by square root of A1 square plus B1 square plus C1 square into square root of A2 square plus B2 square plus C2 square. Now what is OZ? OZ is here, right? You take the what? L into 1, M into 1, N into 1, square root of L square plus M square plus N square into root 3. So therefore, I can write L plus M plus N into root 3 into L square plus M square plus N square. And next, beta is the angle between a line and AE bar, required line and AE bar. So therefore, I can write, which implies cos beta is equal to angle between line and a what? AE. What are the DRS of AE here? Therefore, L1, L2, that is A1, A2 minus L, B1, B2, M, C1, C2, N by root 3 into square root of L square plus M square plus N square. Okay, so now I got it. So therefore, now gamma is the angle between a required line or a ray which makes an angle alpha, beta, gamma, delta correspondingly with the what? 4 diagonals. So therefore, now I can write BF bar, right? BF bar is equal to BF bar. So therefore, now its line is having DRS element. Here BF bar DRS 1 minus 1 1, L into 1, M into 1, this is M into minus 1, this is N, root 3 into square root of L square plus M square plus N square. The students must be aware of this. Here element are the what? DRS, not a DCS, right? So therefore, now delta is the angle between a required line or a ray which makes a delta with what? CD or DC, as you please. Now this is equal to DC. What are the DRS of DC? 1, 1, minus 1. What are the DRS of a required line? LMN. So therefore A1, A2 plus B1, B2 minus C1, C2 by square root of 3 into what? L square plus M square plus N square. Why root 3? Now this length is what? Come on. A1 square plus B1 square plus C1 square is nothing but root 3. Followed? Yes. We got this one as cos gamma. We got this one as what? Cos delta, right? Cos delta. I can write this one as, yes, that is a cos gamma, cos delta. Yes, we are supposed to find out cos square alpha plus cos square beta, cos square gamma, cos square delta, right? Is equal to, you write this one as L plus M plus N whole square. Now here root 3 is the common for what? Denominator. Next this becomes minus L plus M plus N whole square. This is L minus M plus N whole square. This is L plus M minus N whole square by 3 into L square plus M square plus N square. Right. So therefore I can write this one as sigma cos square alpha. Instead of writing all the 4 angles, I can write in what? Sigma notations. So therefore what is that? Come on, expand this. A square plus B square plus C square plus 2AB plus 2BC plus 2CA. Correct? Followed? So therefore now coming, this one is next minus L. This is minus L plus M, right? Minus L plus M plus N. Now L square plus M square plus N square minus 2LM plus 2MN minus 2NL. Right. Next, yeah, that is L minus M plus N. So therefore L square plus M square plus N square minus 2LM minus 2MN, but the next plus 2NL. Next, L plus M minus N whole square, L square plus M square plus N square plus 2LM minus 2MN minus 2NL. Okay. You can very well observe there are 4 brackets, 4 times L is coming. Okay. 4 times of, I can write, that is L square, that is M square, N square. Okay, here also L square, here also L square, here also L square, here also L square. Means 4L square. In the same fashion, M square, M square, M square, M square, 4M square. N square, N square, N square, N square, 4N square. Then what about 2AB, 2AC, 2CA? Now look here. So 2BC. Now plus 2LM minus 2LM get cancels. Here plus 2LM minus 2LM get cancels. Next plus 2MN minus 2MN get cancels. Plus 2MN minus 2MN get cancels. Next, what is that? 2NL, 2NL minus 2NL get cancels. Next, plus 2NL minus 2NL get cancels. Means the part of A plus B plus C whole square, the 2AB, 2BC, 2AC with 2 times alternate signs get cancels, leaving those terms are getting vanished. So therefore we have arrived at, what is that? Now 4 into L square plus M square plus N square plus 0. Plus 0. So therefore now I can write whole divided by 3 into L square plus M square plus N square get cancels. Therefore sigma cos square alpha is equal to how much? 4 by 3. Sigma cos square alpha is equal to 4 by 3 means it becomes cos square alpha plus cos square beta plus cos square gamma plus cos square delta. What we have proved? 4 by 3. Now look here, this is one of the important result here is in a what? Cube. Listen here. So very much confused part here. In a cube, that is A, B, C, D, E, F, G. Okay, E, F, G. Now O is the origin, A is along x-axis, B is along y-axis, C is along z-axis. Let in a cube, length of all the sides are equal. So therefore this is A, this is what? A, this is also A. I have taken A is equal to A, comma 0, comma 0, B is equal to 0, comma A, comma 0, C is equal to 0, comma 0, comma A. So therefore, now next D is a point in xy plane, E is a point in what? YZ plane, G is a point in a space, 3 dimension. Okay, F is a point in what? ZX plane. So therefore, I have taken A, B, C. According to A, B, C, I have taken what? G, D, E. Next F. Let OG, AE, BF, CD be the 4 diagonals, actually 4 diagonals. So therefore, one diagonal is OG, other diagonal is AE, next third diagonal is BF, the fourth diagonal is what? Come on, CD or DC, as you please. So therefore, now 4 diagonals. Let us find out the DRS of OG. Now your G is what? A, comma A, comma A. So therefore, DRS of OG, x2 minus x1, y2 minus y1, z2 minus z1. So therefore, A minus 0, A minus 0, A minus 0, A. Now, so when A, B, C are the DRS of a line, KA, KB, KC, A by K, B by K, C by K are also DRS of a line, 1, 1, 1, right? DRS of AE, A minus A minus A, that is 1, 1, 1, minus 1, 1, 1 are the DRS. DRS of B, BF, 1 minus 1, 1. DRS of DC, 1, 1, minus 1. Let the DRS of a required line be, required line or array, or what? Proportional to L, comma N, M, comma N. We have taken DRS, we have not taken the what? DCS, right? Because when any 3 real numbers are said to be direction ratios, they must be proportional with what? Direction cosines. Okay, that's a concept. As because if you want to take any 3 real numbers, as a DRS, they must be proportional with what? Direction cosines. So therefore, now here is the line which is making an angle alpha, beta, gamma, delta with 4 diagonals. That line must also have what? Direction ratios. Because when we are finding the DRS of a 4 diagonals, now the line, required line must also have the what? DRS. Why? We are finding the angle between the 2 lines in terms of direction ratios. That is A1, A2 plus B1, B2 plus C1, C2 by square root of A1 square plus B1 square, C1 square into square root of A2 square plus B2 square plus CD square. So therefore, LMN are the DRS of a required line. So alpha BN, angle made by the line with the OG. So therefore, now cos alpha is equal to L1 into what? 1 here, L1 into 1, M1 into 1, N1 into 1. So therefore, L plus M plus N by root 3 into L square plus M square plus N square. Don't write it is equal to 1. Now beta is the angle between line and AE diagonal, cos beta, A1, A2, B1, B2, C1, C2. Next, cos gamma. Now angle between line and a BF diagonal. Next, L minus M plus N by root 3 into this cos gamma. Next, cos delta is equal to line and DC. What's the DRS of DC? 1, 1 minus 1. Therefore, L plus M minus N by root 3 into square root of L square plus M square. Now, cos square alpha plus cos square beta plus cos square gamma plus cos square delta. If you simplify that, you are going to get what? 4 by 3 as a value of that. Yes, in the cube, today we have proved many results. One is, look here, one is in a cube. Now the angle between the 2 diagonals of a cube, that is OZ and AE, we proved that as theta is equal to cos inverse of 1 by 3. The angle between the diagonal of a cube and a face diagonal, as what? Theta is equal to cos inverse of square root of 2 by 3. Angle between the what? Diagonal and edge of it, theta is equal to cos inverse of that value 1 by root 3, correct or not? So therefore, next, if a line makes an angle alpha, beta, gamma, delta with what? 4 diagonals, then we have proved sigma cos square alpha is equal to 4 by 3, right? Thank you.